All right, so this is the key to the worksheet on solving systems of linear equations. And in number one, you wanted to use substitution, and in number two, you wanted to use the addition elimination method. So let's look at number one, where we're going to use substitution, and make sure you show all work, all required work to receive all points. But in number one, we have this system of linear equations, and we want to solve this system by using substitution. So we want to find out what ordered pair will make the first equation and the second equation true at the same time. So what ordered pair is going to be a solution to this equation and a solution to this equation. Remember, each of those linear equations has an infinite number of solutions, but the system, this particular system, has only one solution. In this particular case, it has one solution, and you are to find that solution. And remember, when we graph those, the solution is where those two lines would intersect. And they do intersect, and they intersect at one point. And that point is the solution. So let's go ahead and find it. So this is going to be by substitution. Now, when using substitution, what you want to look at to help you, and not all linear equation, not all systems will be this easy in terms of substitution, by the way. But I made this a very simple one so you'll get the idea of using substitution. But the idea is to choose one of those equations, doesn't matter which one, and you want to solve for a variable, either x or y. And you want to do it in such a way to where, if possible, and it's not always possible, if possible, to where if you solve for x or solve for y in either of those equations, you're not going to involve any fractions. Because fractions make things harder, right? It makes things a little bit more difficult for you. So let's see if we can pick an equation and choose a variable in which we're not going to have any fractions. So for example, if, and I'll go ahead and use a separate sheet of paper, but if I were to, let's say, pick the first equation right here, and let's say you want to solve for x. All right, so you would add 5 to both sides, because you would add 5y to both sides, because right now you're subtracting 5y, so you'd end up with something like this. Then you would have to divide by 2. But the point is this: if you look at what you have, when you solve for x, you have fractions. You have 5 halves y plus 3 halves. And so now what you've done was you've introduced fractions. And then that would make things a little bit more difficult for you. You can still solve, but you'd have to be careful with all those fractions that are involved in the solution process. So picking that first equation and solving for x is not going to help, because at some point you're going to have to divide by 2, and you're going to end up with fractions. The same thing for y right here. At some point you'd have to divide everything by -5, and you'd end up with fractions. So let's go to the second equation then. If I go to the second equation, notice that right away, see this variable x that has a coefficient of 1? See, if you have a variable in one of your equations that has a coefficient of 1 or -1, doesn't matter, that's the one you want to pick. So if you look at the second equation, and if you solve for x, that would make things a lot easier for you. If you solve for y, you would have to divide both sides of the equation by -3, and again, you would be introducing fractions. So the first thing is to notice that first of all, you're going to take that second equation, which is x minus 3y equal 4, and you're going to solve for x. So this becomes x equal 3y plus 4. So that's the first thing you have to do. So step 1 in this particular case is to solve for x using the second equation. All right, and then once you solve for a variable, then that's where that substitution comes into play. You're then going to take that expression here, that 3y plus 4, that's equal to x, that 3y plus 4, and you're going to go back to the other equation, that first equation, And wherever you see the variable x, you're going to substitute 3y plus 4. So now using substitution, we get this. All right, so we're going to get 2 times x, and remember x is this expression, 3y plus 4, is equal to, minus 5y equals 3. All right, so remember what we did was we picked that second equation, remember using substitution. So we picked that second equation and we solved for the variable x because it had a coefficient of 1. It'll make things a lot easier for us. Then once we solve for x, we take that expression that x equals 2 and we substitute that into x into that other equation. And so we get 2 times x, which is 3y plus 4, minus 5y equals 3. And that's what you have here. And then now we're going to solve this linear equation for y, because that's the only variable I see is y. So I get 2 times 3y is 6y, 2 times 4 is 8, minus 5y equal 3. Combining like terms, 6y minus 5y is y, so I get y plus 8 equal 3. Subtract 8 from both sides, I get y equals, this is 0, I get y equals, and then 3 subtract 8 is a negative 5. So I found, so far, my solution, if you think about it, my solution, remember your solution is an ordered pair, So an ordered pair, meaning that if I were to look at this in terms of a coordinate plane, my solution is an ordered pair in a coordinate plane. It has an x-coordinate and a y-coordinate. All right, so I found my y-coordinate to be negative 5. Now all I need to do is find my x-coordinate. Okay, so now we have to find x. So basically, mathematically, what you should do is to find x, go back to one of the original equations. And wherever you see the variable y, you substitute negative 5. It does not matter which one, by the way. It does not matter which one. What many students do is they go back to that expression, that equation where they got x by itself. The problem doing that is you could have easily made a mistake somewhere around here. So you could have made a mistake solving for x. So I'm going to just go back and I'm going to go ahead and use either of those equations in the original, because that's technically what you're supposed to do. Just go back to either one of those. It does not matter which one, and solve for x. All right, and we'll do both just to show you that you'll get the same x value. So let's go to the second one. Second one may be easier to deal with first. So let's find x. So where we see so to find x, we're gonna substitute negative 5. So substitute negative x. So negative 5 into y, and so get x minus 3y equal 4, right? So where we see the variable y, I'm going to substitute negative 5. So I get x minus 3 times negative 5 equals 4. A negative 5 times a negative 3 is 15, positive 15. And then to get x by itself, we're going to subtract 15 from both sides. And so these combine to give you 0. So x plus 0 is x equal, and then 4 minus 15 is a negative 11. So that is my x value. Now, if I had gone back to the to the first equation instead, I should still get the same value. Okay, so let's do that. And I'm going to go ahead and just use another sheet of paper. So you could have used 2x minus 5y equal 3 to solve for x. So y is negative 5, so we get 2x minus 5 times negative 5 equals 3. 5 times negative 5 is positive 25, so I get 2x plus 25 equals 3. So to solve for x, we're going to subtract 25 from both sides, and so I get 2x equal 3 subtract 25 is a negative 22, right? And then to get x by itself, we divide both sides by 22, and notice I get x to be negative 11. So again, it did not matter which of those equations you chose. Okay? So there's your solution. So the ordered pair that makes this system a true statement, meaning that what x value, what y value will make the first equation and the second equation true at the same time. Where do those two graphs intersect on the in the coordinate plane? And basically what you found is that they intersect at negative 11. What was it? Negative 11, negative 5. So negative 11, somewhere around here, and then negative 5. So if I were to draw those two graphs, that's where they would intersect. All right? Okay, but that's the process. So that's substitution. So substitution, you're going to you're going to choose one of those equations, and you're going to choose for a variable. You're going to solve for a variable. And you want to choose something, if you can, in which you don't have any fractions. And then you're going to take that, substitute into the other equation, that's what we did here, and solve for the variable. To solve for the other variable, you substitute what you just found into either one of those equations. Doesn't matter, to solve for the other variable, and you're done. So that's how you do it. All right, so that was number one. Number two, we have this system. All right, so here's number two. All right, so number two, we have negative 4x minus 15y equal negative 17, and we have negative x plus 5y equal negative 13. Now it's very important that you follow directions. So the directions said to use addition elimination. So be careful. If you were not told how to solve this, then you could have gone x by itself and used substitution fairly easily. All right, but you are told to use addition elimination. All right, so what you got to do with addition elimination is at some point, remember, at some point you're going to be adding those two equations. And when you add those two equations, you want one of those variable terms to be eliminated. That's the idea. So hence, add, and you want to eliminate. Okay? All right, in order to do that, though, in order for either the variable terms x or the variable terms y to be those coefficients have to be opposites of each other. And so that's what you got to determine. What do I need to multiply either of those equations by to get these coefficients to be opposites, either the x's or the y's? Okay? Does not matter. So listen to the thought processes as I go through this, and that's what you should have done when doing this problem. So let's suppose someone wants to eliminate the x. All right, so let's go ahead. Now someone could have eliminated the y's. Does not matter. Either the x or the y's. So let's go ahead and eliminate the x. All right, so let's think about this. If I'm going to eliminate the x, then I need those coefficients to be opposites. So this is a negative 4, this is a negative 1. So what you need to do is think about what is the least common multiple of negative 4 and negative 1. What's the smallest number? And always use the smallest, it helps. It helps if you use the smallest. So what's the smallest number that negative 4 and negative 1 go into? Well, negative 4 and negative 1 goes into 4, right? 4 and negative 4. It goes into 8 or negative 8. It goes into 12, negative 12, evenly, and so on. But let's use the smallest. So meaning that I want one of those to be a positive 4 and one of those to be a negative 4. All right? So your least common multiple, so you want to find out what's the smallest number that this coefficient and this coefficient go into. So either you could say 4 or you could say negative 4. Doesn't matter. All right? Okay, now, notice though that this is already a negative 4. But this is, remember, you want this to be opposite, so you want this to be a negative 4, then that means you want this to be a positive 4. Because if you add those, a negative 4x and a positive 4x is 0. So I need this to be a positive 4 here. All right, so to do that, then that means, see, it's already negative 1. So that means I've got to multiply this by a negative 4. That's what that means. So a negative 1 times a negative 4 is a positive 4. So we're going to do, the way I'm going to do this is this. So let me go ahead and rewrite this over. All right, so I'm going to go ahead and rewrite this over. And what we just said was this. What we just said was I need to multiply. Now remember, you're multiplying each side of this equation. What you do to the left, you have to do to the right. So I'm going to multiply this side by negative 4, and I'm going to multiply this side by negative 4. All right, so let's go ahead and do that. So this right here becomes this system. So those are equivalent systems. So negative 4x minus 15y equal negative 17. I didn't do anything with that first equation, but I did multiply both sides of that second equation by negative 4. So a negative 4 times a negative x, I'm using the distributive property. A negative 4 times a negative x is a positive 4x. A negative 4 times a positive 5y is a negative 20y equal, and the negative 13 times 4 is a positive 52. All right, now at that point, if you're doing this correctly, at that point, either the x terms or the y terms are going to be opposites. And in this case, it was the x terms because that's what I wanted to eliminate. So now I'm going to add those. So I'm going to add those two equations. Negative 4x plus 4x is 0. A negative 15y and a negative 20y is a negative 35y equal, and if you have to use your calculator, use your calculator. A negative 17 plus 52 equals equals a positive 35, right? So that's 35. All right, well that's going to make things easier on me because notice that to get y by itself, let me go ahead and rewrite this over. To get y by itself, I'm going to have to divide both sides by negative 35. What you do to one side, you do to the other. Negative 35 divided by negative 35 is 1. 1 times y is y equal. And notice 35 divided by negative 35 is a negative 1. So you found the, and I'm going to go ahead and put that here, solution. You found the y coordinate of your solution, of the ordered pair, and that is negative 1. Now we have to go back and find the x coordinate. And remember, that's where you go to the original problem. Does not matter which of those equations you choose. We saw that in number 1. Does not matter. So now we have to solve for x. We found y. Now we have to solve for x. So let's go back to the first one. We have negative 4x minus 15y equal negative 17. Does not matter whether you use the first one or the second one. You'll get the same value for x. You could try it. You'll see you will. So wherever you see the y now, I'm going to substitute negative 1. So in place of y, I'm going to substitute negative 1. So I get negative 4x minus 15 times negative 1 equals a negative 17. A negative 15 times a negative 1 is a positive 15. So I get negative 4x plus 15 equal negative 17. Subtracting 15 from both sides, solving for x is a linear equation. This is 0. Negative 15 positive 15 is 0. I get negative 4x equal a negative 17 and a negative 15 is a negative 32. So if you have to use your calculator, use your calculator. Negative 17 plus a negative 15 is a negative 32. And then to get x by itself, let me just go ahead and rewrite this over. To get x by itself, we're going to divide both sides by negative 4. And the negative 4 divided by negative 4 is 1. 1 times x is x. Equal. And a negative divided by negative is a positive, right? So remember, make sure you use all your mathematical knowledge. 32 divided by 4 is 8. So there's my x coordinate. So the solution is x negative 1. So when x is 8, y is negative 1. All right, let's check this. I just want to show you that you can check this. So let's just check. You don't have to check. You don't have to check these. But if you have time, check. Make sure that what you did is correct, that none of this work you did here has an error in it. So let's just check to make sure what I have is correct. So you go back to the original. You always have to go back to the original. Negative 4x minus 15y equal negative 17. Negative x plus 5y equal negative 13. All right, so we're checking the solution 8, negative 1. All right, but you have to check both equations to make sure that the left-hand side equals the right, the left-hand side equals the right. All right, so let's do the first one. Negative 4x minus 15y equal negative 17. So in place of x, I'll substitute 8, and in place of y, I'll substitute negative 1. So I get negative 4 times 8 minus 15 times negative 1, and I want to see if that's going to equal to a negative 17. Well, negative 4 times 8 is a negative 32. A negative 15 times a negative 1 is a positive 15. Negative 32 plus 15, use your calculator, you're going to see that's equal to negative 17. But if you do that, okay, let me move this a little further. All right, so if you do that, you're going to say negative 32 plus 15 equals negative 17. All right, and that's what you wanted. So this solution satisfies the first one, but you got to check the second one. You have to do both. All right, so let's go to the second one. The opposite of x, or negative x, plus 5y equal negative 13. So in place of x, I'll substitute 8. In place of y, I'll substitute negative 1. So I get negative 8 plus 5 times negative 1. And I want to see if that's going to equal to a negative 13. Well, this is negative 8. 5 times a negative 1 is a negative 5. And a negative 5 and a negative 8 is indeed a negative 13. All right, so what you found is that you did not have any errors here, at least numerically. I mean, remember, I do check to make sure that all your statements are mathematically correct. All right, so for example, if you said divide both sides by negative 5y, that's not mathematically correct. All right, so just be careful about your statements. But that's it. So that is your solution. All right. Now remember, the way we did this was we first of all eliminated x. All right. So to eliminate x, the least common multiple of negative 4 and negative 1 is either 4 or negative 4. All right. And so so notice I got one to be negative 4, the other to be a positive 4, because I needed those to be opposites. If someone had eliminated the y's, so let's talk about that. Let's do number 2 using y's. I think it won't take that long. So let's do number 2. So I'm going to do number 2. This time I am going to eliminate the y instead, because some of you could have done that. So instead of eliminating the x's, some of you could have eliminated the y's instead. So if I'm going to eliminate the y's, I got to look at the coefficient of what I have. I have a negative 15 and a positive 5. The least common multiple of a negative 15 and a positive 5, the smallest number that negative 15 and a positive 5 go into, is either 15 or negative 15, right? Okay, so this is already a negative 15, but this is a positive 5. And remember, just like the previous one, you needed one to be positive, one to be negative. So notice this was already negative, so I made this one positive. Negative 15 is already negative, so I need this to be a positive 15. All right, so let's go ahead and eliminate the y. So eliminate the y, you found the least common multiple to be 15. All right, so this is negative, then this has to be positive. So let me go ahead and just go ahead and rewrite this over. All right, so I'm going to multiply, this is 5. 5 times 3 is 15. So I'm going to multiply both sides by 3. And you're going to see you can get the same answer. You're going to get 8, negative 1. All right, so this becomes negative 4x minus 15y equal negative 17. Just use a distributive property. 3 times negative x is a negative 3x. 3 times 5y is positive 15y equal, and then negative 13 times 3 is a negative 39. Now, since these are opposites, negative 15y, positive 15y, I can add them up, and those are eliminated. Negative 4x and a negative 3x is a negative 7x equal. Negative 17 plus 39, use your calculator if you have to. Negative 17, let's do this again. All right, negative 17 plus a negative 39 equal negative 56. So that's a negative 56. Then we got to solve for x, and I'm just going to rewrite this over. So I'm going to have to divide both sides by negative 7. And when I simplify, negative 7 divided by negative 7 is 1. 1 times x is x, equal. And then negative 56 divided by a negative 7, hopefully you're going to say it's positive, right? Positive 8. And so notice I got x to be 8, which is what we said it should be. Then to solve for y, you do what we just did in the previous problem. So now we got to solve for y. So far, my solution is x coordinate of 8. Now I got to find y. So we got to solve for y. All right. So to solve for y, I'm going to use either one of those equations. I'm going to use the second one this time because in the first one I used the first equation. So let's use the second one this time. So we're going to have negative x plus 5y equal negative 13. So in place of x, I'm going to substitute 8. So this becomes negative 8 plus 5y equal negative 13. So to solve for y, I first of all have to get rid of this negative 8. So I'm going to add 8 to both sides. A negative 8 plus 8, 0. 0 plus 5y is 5y equal. A negative 13 plus 8 is a negative 5. And then I'm going to go ahead and divide both sides by 5. 5 divided by 5 is 1. 1 times y is y equal. A negative 5 divided by 5 is a negative 1, and there's my other solution, and that's what we had. Okay, so that's how you do this. Someone could eliminate the x and got y to be negative 1, and then substitute to get the variable x. And then someone else could have eliminated the y's, got x this time, substitute to solve for y. All right, so that was number 2. And then, well, that was actually, I guess it's 2a. So this was 2a. In 2b, we have this system. So 2b was this system. So let's go ahead and do that one. Now, I'm not going to do it both ways because remember, someone can eliminate the x or someone can eliminate the y. It does not matter which one, okay? But I'm getting close to 30 minutes here, so I'm just going to do one of them. All right, so let's go ahead and rewrite the problem. So this is 2b. I have 3x minus 2y equal negative 2, 5x minus 6y equal 10. All right, so let's suppose we want to eliminate the x's. All right, eliminate the x's. All right, if I'm going to eliminate the x's, remember the least common multiple. What's the smallest number that 3 and 15 go into? Always use the least. Makes things easier on yourself. So what's the smallest number that 3 and 5 go into evenly? Well, that's going to be 15, right? Okay. Remember, though, when you rewrite this, you want this, if you're going to eliminate the x's, you want these terms to be opposites, meaning one's going to be positive, one's going to be negative. Notice they're both positive, so you're going to have to make one of them negative. All right, so keep that in mind. Now, I'm just going to say this now. If someone had eliminated the y's, the least common multiple of negative 2 and negative 6 is 6, right? All right, so eliminating the y's may be more efficient in this case, but not that much more. So it did not matter whether you eliminate the x or the y. It doesn't matter. I'm just going to eliminate the x. Okay, so I'm going to go ahead and rewrite this over. Now listen carefully to what I'm doing. All right. Okay, so if I'm going to eliminate the x's, I want this to be 15 and this to be negative 15. Or I could make this negative 15, this positive 15. Does not matter. So let's say I want this to be 15. So you got to multiply 3 by what number to get 15? Well, that's going to be 5. So you're going to say times 5. Well, what you do to one side, a lot of students forget about this. You have to do to the other side. Don't forget that. So if this is going to be 15, then I need this to be a negative 15, right? So then I've got to multiply the left-hand side by negative 3 this time. Because negative 3 times 5x is a negative 15x. But what I do to the left, don't forget, you have to do to the right. And so now, using distributive property, this system is equivalent to this now, meaning they're going to have the same solution. So distributed, you get 5 times 3x is 15x. 5 times a negative 2y is a negative 10y equal negative 2 times 5 is a negative 10. For the second equation, negative 3 times 5x is a negative 15x. Can't you see the opposites right here? Negative 3 times 6y is a positive 18y equal, and then negative 10 times 10 times a negative 3 is a negative 30. Now, at that point, you should be able to add those, and one of the variables should be eliminated, and it should be the x, and it is. Negative 15x and positive 15x is 0. Negative 10y and 18y is 8y. So that is 8y equal negative 10 and a negative 30 is a negative 40. Dividing both sides by 8, I get y to be a negative 5. So there is, so think about your solution. So far I know that the y coordinate of my solution is going to be a negative 5. All right, so that's how I got y. To get y, you're going to eliminate the x's, and then you're going to solve for y. But now you got to solve for x, right? So now we're going to solve for x. Now to solve for x, remember, you go back to one of those equations. It does not matter which one. You'll still get the same answer, the same value for x. So let's just go to the first one. So we have 3x minus 2y equal negative 2. So in place of y, I'm going to substitute negative 5. So we get 3x minus 2 times negative 5 equals a negative 2. Negative 2 times negative 5 is a positive 10. So I get 3x plus 10 equals negative 2. And then to solve this linear equation for x, we're going to subtract 10 from both sides. And so I get 3x is equal to negative 2, and a negative 10 is a negative 12. And then to get x by itself, we're going to divide both sides by 3. Reduce, I get 3 divided by 3 is 1. 1 times x is x equal negative 12 divided by 3 is a negative 4. And so my solution is negative 4, negative 5. Now, if you have time, you should always check this, especially if those are integers. So let's just check it. So we're going to check negative 4, negative 5. All right, you go back to the original. So here's my original. And when you go back to the original, you have to check both equations. So let's do the first one. So 5x minus 2y equal negative 2. That's 3x, sorry. 3x minus 2y equal negative 2. That's the first one. So in place of x, I'll substitute negative 4. In place of y, I'll substitute negative 5. So 3 times negative 4 minus 2 times negative 5. And I want to see if that left-hand side is going to equal negative 2, the right-hand side. 3 times negative 4 is negative 12. A negative 2 times negative 5 is a positive 10. Negative 12 and a positive 10 is a negative 2, which is what you wanted. But you got to check the other one. Don't just check one of them. 5x minus 6y equal 10. So remember, you're finding the solution satisfies both. So you got to check to make sure that it actually satisfies both. So we get 5 times x. X is negative 4. Minus 6 times y, which is negative 5. And you want to see that's going to equal 10. 5 times negative 4 is a negative 20. Negative 6 times 5 is a positive 30. Negative 20 plus 30 is a positive 10, and that's what you wanted. So what you found is that the solution is indeed negative 4, negative 5. All right, so that was 2b, and that was the work you would show if you had eliminated the x's. All right, so to eliminate the x's, your least common multiple is going to be 15, so you need one to be positive, one to be negative. Now, I'll go ahead and show you what the work you would have done if you had eliminated the y. So let's just quickly do that. I'm not going to check it because you know how to check it, but we'll just go ahead and eliminate the y's, just because some of you did that. And so here was my original system. It was 3x minus 2y equal negative 2, and then 5x minus 6y equal 10. So if I had eliminated the y's, the least common multiple of negative 2 and negative 6 is 6. And you could say, with no issue, you could say negative 6 as well. It does not matter. I'm just going to put positive 6. All right, now, remember though, the smallest number that I'm saying, negative 2 and negative 6 go into evenly is 6, right? Okay, so I need one of these to be a positive 6 and the other to be a negative 6. You'll notice that one of them is already a negative 6. So all I need to do is change this one. All right, so let's talk about that. So let me go ahead and rewrite this over. 3x minus 2y equal negative 2. 5x minus 6y equal 10. So this is already negative 6. That means I need this to be a positive 6 in order for them to be opposites. So in order to get that to be a positive 6, I need to multiply negative 2. So negative 2 times what number is a positive 6? Well, negative 2 times a negative 3 is a positive 6. But what I do to the left, I have to do to the right. So notice, for those of you that eliminated the y's, you only had to multiply one equation by a number. Whereas for those of you that had eliminated the x's, you had to do both. All right, so let's go ahead and rewrite this. So negative 3 times 3x is negative 9x. Negative 3 times a negative 2y is a positive 6y equal, and negative 2 times a negative 3 is a positive 6. I didn't do anything to the second equation, so I'm just going to go ahead and rewrite it over. And now I'm going to add those. So when I add those, negative 9x and 5x is a negative 4x. These are eliminated because that's what I want. I wanted to eliminate the y, so those had to be opposites. And then that's going to equal 6. See, that's 0 here, right? And that's going to equal 16. 6 plus 10 is 16. So I get negative 4x equal 16. Then dividing both sides by negative 4, negative 4 divided by negative 4 is 1. 1 times x is x. So I get 16 divided by negative 4 is a negative 4. So that's what we said the x coordinate was, remember? Negative 4. So far I know my solution, x is negative 4. Now all I have to do is solve for y. To solve for y, I go back to the original and I choose one of those equations. It does not matter which one. I'm going to choose the second one this time. It did not matter though, but I'm going to go ahead and choose the second. So in place of x, I'm going to substitute negative 4 to solve for y. So I get 5 times negative 4 minus 6y equals 10. 5 times negative 4 is a negative 20, so negative 20 minus 6y equals 10. Adding 20 to both sides, negative 20 and 20, 0, 0, and a negative 6y. Be careful, that's a negative 6y, not 6y. A negative 6y equal 10 and plus 20 is 30. And then to get y by itself, I'm multiplying y by negative 6. The opposite of multiplication is division. So I'm going to divide both sides by negative 6. Negative 6 divided by negative 6 is 1. 1 times 6y is, 1 times y is y equal 30 divided by negative 6 is a negative 5. And that's what we saw we had, right? We needed y to be negative 5. And that's your solution. And you could check that one as well. You would get, it would look just like this, by the way. This, if you check, would be what you would put here. Okay, so that is it. So that is the key to these three problems. All right, so don't forget the works. Make sure you show all steps. Okay, don't skip any steps. You must show all steps. All right, so that is the solution to those three problems.